Hello and good morning, everybody. Happy Tuesday. It's Taco. Let's get into math. I wore the right shirt today. I'm winning, everybody. I'm frickin' winning. Okay, today we are subtracting fractions with unlike denominators. Sounds scary. It's not as bad as you think. Trust me. All right, here's what you need. Same things as previous lessons, something to write on, something to write with, and your multiplication table. If you have one, if you're using the online one, that's great too. And then down here are our teaching points and our ICANs for the day. I can create equivalent fractions, and I can subtract fractions with unlike denominators. All right, let's get into it. So, thinking about adding and subtracting of whole numbers. They're inverse operations, right? They do the opposite thing. Adding something, there's more of it. Subtracting something, there's less of it. Same thing with fractions. And then the same rules apply to subtracting fractions as they do for adding fractions. You need to have the same or a common denominator in order to accurately add and subtract those fractions. Otherwise, you don't know what measurement or what unit your answer is going to be in. For instance, if you have something like this, 2/3 minus 1/4, you know that with its subtraction, right, you know that this bit minus this bit is going to give you about that much left. That's going to be our difference. But how much is this? If we're not working in a common unit, then we don't actually know what to name this amount. It could be a million, it could be 1, it could be 5, it could be blue, it could be blargle, who knows, right? So what we need to do is we need to make sure that, like with addition, we have the same size denominators. So if we've got 2/3 and 1/4, we need to make sure, and we need to figure out what our common denominator is going to be. So if we take a look at the 3's column for our thirds and the 4's column for our fourths, what number shows up in both, meaning they're a common multiple? That would be 12. Okay? 4 times 3. So we're going to take our fourths and cut each fourth into 3 pieces. Okay? Then we'll take our thirds. Where does 12 show up? We're going to cut that into 4. We're going to cut each one into fourths. And lo and behold, if we zoom in here, now our pieces are the same size. Look at that. Oh my gosh, if we do that in number terms, we have our 2/3 equals how many pieces total? We already said there was 12. We're going to rewrite it down here. And then how many pieces shaded in? What's our numerator? 1, 2, 3, 4, 5, 6, 7, 8. Minus 12 in our denominator. And how many pieces shaded in? What's our numerator? 1, 2, 3. 8/12 minus 3/12 equals, denominator stays the same because we're not changing the size of our piece. Subtract the numerators. 8 minus 3 equals 5. And you can see that here. If we were to take those away, we're left with 1, 2, 3, 4, 5 pieces. And each piece is equal to 1/12 of the whole. If we were going to do that by multiplying our equivalence of 1, it might look, where's my eraser? There you are. It might look like this. If our 2/3 minus 1/4, okay? And we know that our answer is going to be in twelfths because that is our least common multiple between our 3's and our 4's, okay? So let's rewrite it below. We're going to have some form of twelfths minus some form of twelfths equals some form of twelfths. So let's figure out 2/3 times some equivalent of 1 is going to equal twelfths. So 3 times what is 12? 3 times 4 is 12. So our equivalent of 1 in this case is going to be 4/4. Multiply straight across. 2 times 4 is 8. So we know that this 2/3 is equivalent to 8/12. The reason I wrote it right below is so I know clearly these are equivalent, these are equivalent, these are equivalent. It's the exact same equation, just written in different terms with different denominators. Now let's look at our 1/4 equals how many twelfths? So 1/4 times some sort of equivalent of 1 to get twelfths. 4 times what is 12? 4 times 3 is 12. So we're going to use 3/3. 4 times 3 is 12. 1 times 3 equals 3. So we know we have 8/12 minus 3/12, and that's going to get us our answer of 5/12. Okay? I hope you're noticing that when I find my common denominator, I'm writing it in for all of them automatically. Because I want to remember that my denominator is not going to change when I add or subtract. Okay, that's going to be my clue. So if I pre-write my denominator, my common denominator, into the equation, then I just have to worry about how many pieces there are. It just becomes as simple as 8 minus 3 equals 5. Okay? Let's try one more. Again, same process as adding fractions with unlike denominators. We have to figure out what that common denominator is going to be. Then we've got to convert our fractions into that common denominator, and then we can do our operation. In this case, subtraction. So let's try something like this. Let's try 5/8 minus 1/3. Let's go 5/8 minus 1/3 equals what? So we're going to go to the 8s, see what we can convert this fraction into. So it could be 8s, 16s, 24, 32. Let's figure out which one of those numbers shows up in the 3's column. 3, nope, 8 would be here. 16 is the next one. No, 16 would be there. What's next? 24. 24 is there. So we know our least common multiple, our common denominator for this is going to be 20/4. So when I rewrite my problem below, I'm going to write in 20/4 for all of them straight away, so I don't have to worry about it anymore. Now, let's convert. So 5/8 times an equivalent of 1 equals some sort of 20/4. I'm putting this in my 1 box so I remember. Whoop, there we go. Now let's think about 8 times what is 24? 8 times 3 is 24. So I'm going to use that 3/3 equivalent of 1. 8 times 3 is 24. 5 times 3, 15. So that means 5/8 is equivalent to 15 24ths. Now let's do our other one. 1/3 times something is going to equal 24ths. So what equivalent of 1 do we need here? 3 times what is 24? 3 times 8 is 24. 3 times 8. So we're going to use 8/8 as our equivalent of 1. 3 times 8 is 24. 1 times 8 is 8. So we know 8 24ths is equivalent to 1/3. And now we've already got the denominators written in. We can just subtract the numerators. 15 minus 8, or 15 minus 5 minus 3, would be 7. So our final answer here is 7 24ths. Okay? If it seemed a little quick, it's because it was. We're going to go to the digital whiteboard in just a second and do some more practice. Here we go. Okay. First one here. 5/6 minus 1/2. So think about, and take a look at our, find your denominators, find your 2's row, find your 6's row. What is the smallest number, the number with the least value, that appears in both of those rows? Does 6 appear in the 2's row? You bet it does. So use 6ths here. Okay, the reason for that is, let's make this as simple as we can here. So we're going to use 6ths. When we rewrite it below, we already know how much 5/6 equals in sixths. It equals 5/6. Simple as that. Now all we've got to do is figure out how many sixths equals 1/2. And we can do that by going back to our multiplication chart and going, okay, 2 times what equals 6? 2 times 3 equals 6. So what we'll do here is do 1/2 times 3/3, because that's going to get us our sixths, equals 2 times 3 is 6. 1 times 3 is 3. So we end up with 5/6 minus 3/6. We've already got our denominators in, so subtract the numerators. 5 minus 3 equals 2. So we end up with 2/6. And some of you smart cookies might be going, can't you reduce 2/6? Let me draw it out here. So here's 1, 2, 3, 4, 5, 6. Thank goodness for graph paper. And then I'm going to shade in 2 of them. Okay, what am I noticing here? Does it look like a fraction familiar to you? Looks a lot like 1/3, doesn't it? In fact, it is. Okay, our 2/6, if we again divide, because we can divide both of these numbers by 2. We can divide 2 divided by 2 equally and 6 divided by 2 equally. So by dividing by an equivalent of 1, just like multiplying, it doesn't change the value of our fraction. We're just creating different sized pieces. 2 divided by 2 is 1. 6 divided by 2 is 3. To create 1/3. Both answers are mathematically accurate. Okay, 1/3 is just a little neater because there's fewer pieces to deal with. We're only dealing with 1 out of 3 pieces versus 2 out of 6. They are equivalent fractions. Okay, so both answers are acceptable. 1/3 is the simplest possible answer. Okay, let's try one more here. Let's try, there's 2 options. Which one should we go with? Let's go over here. Let's try 7/8 minus 1/3. Okay, think about, find that eights row, find that threes row. If you remember back to one of the problems we did on the in real life whiteboard, you'll remember what that least common denominator is. And you are astute in that. It is 20/4. Okay, so rewrite your problem below. Oops, wrote that too big. Zip. There we go. Okay, so now, how many eighths, or how many 20/4 does 7/8 equal? Use that equivalent of 1. 8 times what equals 24? Use that equivalent of 1. Seven eighths times 3/3, right? Because 8 times 3 equals 24. So now all you have to do is 7 times 3, which equals 21. So we're going to have 21 20/4 minus, and does anybody remember how many 20/4 1/3 equals? It's behind me, if you can see it in the tiny little inset bar there. There it is. 1/3 equals 8 20/4. So let's just use the 8 straight away. Why do math a second time if you've already done it once? Okay, numbers are great in that if you do the same thing every time and you do it accurately, you're going to have the same outcome every time, right? There's a reason why we don't have to prove that 3 minus 2 equals 1 every time we do it in a larger problem. It's because we've done it already. Once you've proven it's true, it's always going to be true. 3 minus 2 won't suddenly be 6. 3 minus 2 won't equal 4 only on Thursdays or only after midnight, right? 3 minus 2 is always going to equal 1. Just like 1/3 is always going to be equivalent to 8 20/4 every single time, okay? And the more practice problems you do, continue to think about and make those connections so that the next time you do it, you don't have to do that math again, right? You can think about, oh, 1/3 always equals 3/9. So I don't have to show that on my paper if I've already shown it and I know it, right? So now let's do 21 minus 8. Whatever strategy works best for you. Some people might want to go 21 minus 10 and then add that 2 back because 8 plus 2 is 10. Or you might want to do 21 minus 1 and then minus 7 more because 8 equals 7 plus 1. In any event, it's always going to get you to 13. So our final answer, because 13 is prime and 13 doesn't go evenly into 24, is going to be 13 20/4. All right, before you do the exit ticket, go ahead and try this one. 2/3 minus 2/7. Two-thirds minus 2/7. Scoot it over a little bit more here for you. Give that a try. I'm not even going to do it straight away yet. Just give it a try. Meanwhile, I will remind that this is a process. Okay? And this is a process made even harder by the fact that we're trying to do it via a live stream rather than doing it in the classroom. Okay, so if it feels challenging for you, one, I'm sorry, and I empathize with it because it's not easy. Distance learning is not easy for anybody, teachers, students, families. It's not easy for anybody. Okay, but be patient and give it time. We're going to keep working on it. We're going to keep reviewing it. And even if it's not coming right now, that might be frustrating, but it will come and it will click. Promise. Okay, let's try it. 2/3 minus 2/7. Okay, so if we look at our chart, 7, well, that doesn't. 7 divided by 3 has a remainder. 7 plus 7 is 14. No, because 3 times 4 is 12, and 3 times 5 is 15. That doesn't work. 21, well, I know that's 3 times 7, so I know that's going to work. So we're going to use 21sts here. So we're going to have some form of 21sts minus another form of 21sts to get us our difference in 21sts. Okay? 3, I'm going to try something different here, but it's still the same math. So I'm going to do my equivalence of 1 up here. I'm going to use 7/7 because I know that 7 times 3 equals 21. And 2 times 7 equals 14. So I know 2/3 is equivalent to 14 21sts. Now, 2/7. Well, I know that's, we're multiplying it by 3/3 because 3 times 7 is 21. So now, what's 3 times 2? 6. So then we know that 2/7 is equivalent to 6 21sts. And when we subtract 14 minus 6, we end up with 8 21sts. And that's going to be our final answer, because 8 and 21, believe it or not, do not have any common factors. 8, you can do 1 times 8 or 2 times 4. But with 21, you can only do 1 times 21 or 3 times 7. So they don't have any factors in common. So we can't reduce this one. So it has to stay 8 24ths. All right, everybody. The exit ticket should be up on Google Classroom. Do your best with it. Give it a try. No secret word today, but just some bonus problems for bonus points in the exit ticket. If you need extra coaching, extra support, want extra practice problems on anything, not just subtracting of fractions with unlike denominators, but on anything. If you want to make some more equivalent fractions, if you want to practice reducing fractions, heck, if you want to practice long division, come to the Zoom room, drop in, try some problems, work it out, ask questions, get what you need, and you'll do just fine. I believe in you. Okay? Thank you, everybody, for tuning in. It's been wonderful to digitally see you, and have a great rest of the day. Take care.